All right, so at the end of the last video, we have this takeaway that gives us a recipe, not a simple recipe, but it gives us a recipe to find the matrix corresponding to linear transformation when you've picked a basis for the domain and you've picked a basis for the codomain. So let's try it here. All right, so example 2.4.3, consider the map T from P2 to M2 cross 2, where TP of x just evaluates the polynomial at 4 different points and puts those values in a matrix. All right, so I'm going to take this basis for P2, so 3 generators, and this basis for M22. So I'm not using the standard bases for either, just to really show you the work that you have to do if it's not obvious. All right, so I want to find the matrix corresponding to this linear transformation if I'm using these bases. All right, so I need to look at the first basis vector, 1, and I need to apply t to it. So the function is just 1. So whether I evaluate it at 0, at 1, at -1, or at 2, I get 1, 1, 1, 1, 1. All right, so I want to write 1, 1, 1, 1, 1 as A1. Well, actually, let's use C1. I want the coordinate vectors of this with regards to this basis, so I need to solve for C1 through C3 here. If I put it together, I get C1 plus C2. I get C2, C1 plus, oh, I put C2 twice. That's why I was so confused. C3, C4. So C1 plus C2, C3 plus C4, C3 minus C4, and C1 minus C2. All right, so I need C1 plus C2 to be 1. I need C3 plus C4 to be 1, C3 minus C4 to be 1, and C1 minus C2 to be 1. And so let's take 1, 2, 3, 4. If I take 2 plus 3, I get that 2C3 is 2, and so C3 is 1, which means that C4 is 0. And then same thing for 1 and 4. If I add them, I get that 2C1 is 2, so C1 is 1, and C2 is 0. All right, so the C's that you find, those are going to make up the column. So here, this is the first element, that's going to be the first column. So what we have is that T1 in the basis of M22 is 1, 0, 1, 0. All right, let's do the next one. So that's going to be your first column. I'm going to look at 1 plus x. So I want to apply t to 1 plus x, and then I have to write it in terms of my basis. So I'm applying this function to 0. So I'm plugging in x equals 0. I get 1 plus 0, I get 1. I'm plugging in 1. I'm plugging in -1. I'm plugging in 2. And so I get 1, 2, 0, 3. And again, I want to write it as a linear combination. So let me just write this directly since we've already done this work once. So I want to write it as C1 plus C2, C3 plus C4, C3 minus C4, C1 minus C2. So I need C1 plus C2 to be 1. And let me write the fourth one right away. I know these two are going to come together. So from this, I add them. and I get that 2C1 is 4, 2C1 is 4, and if I subtract them, I get that 2C2 is minus 2, and so I get C1 is 2, C2 is minus 1. All right, so that took care of this one and that one. Let's look at C3 and C4. C3 plus C4 needs to be 2. C3 minus C4 equals 0. So C3 and C4 are equal. And if you put them together, if you add them, you get 2C3 is 2. And if you subtract them, you get that 2C4 is 2. And so C3 is 1, C4 is 1. And so my vector is 2 minus 1, 1, 1. All right, so hopefully you're getting the hang of this. Let me just give you the final one since I'm low on space. X plus x squared, if you want to try it out, that's going to give you the vector. Actually, let me write it horizontally so I have room for my matrix. It's 4 minus 3, 2, 1. And so actually, 4 minus 3, 2, 1. And so the matrix in total using those two bases is going to be, all right. I still see all three, so I'm going to use first one here. The second one is going to go here. And the third one is going to go here. All right, so this is my matrix.